Arulmigu Palaniyandavar Arts College for Women, Palani, PG Department of Chemistry. I am Mrs. T. Anandi, Assistant Professor, PG Department of Chemistry. Mass spectroscopy. Mass spectroscopy is an analytical spectroscopic tool primarily concerned with the separation of molecular species according to their mass. In this mass spectroscopy, we determine molecular weight, molecular formula, structure, isotopic incorporation or distribution, protein sequence. Applications of mass spectroscopy. In the mass spectroscopy is used in pharmaceutical analysis, biomolecular characterization, environmental analysis, forensic analysis. Principles of electron impact mass spectroscopy. Atom or molecule is hit by high energy electron. Electron is deflected but transfers much of its energy to the molecule. This energy-rich species ejects an electron, forming a positively charged odd electron species called molecular ion. Atom or molecule is hit by higher energy electron from a electron beam at 10 electron volt, forming a positively charged odd electron species called molecular ion. The molecular ion passes between poles of a magnet and is deflected by magnetic field. Amount of deflection depends on mass to charge ratio. Highest M by Z deflected least, lowest M is deflected most. If only the ion that is present in the molecular ion, mass spectroscopy provides a way to measure the molecular weight of the compound and is often used for this purpose. The molecular ion often fragments a mixture of species of lower than M by Z. The molecular ion dissociates to a cation and a radical. The molecular ion dissociated to cation and a radical, usually several fragmentation pathways are available and a mixture of its ion is produced. Mixture of ions of different mass gives separate peak for each M by Z. Intensity of the peak proportional to the percentage of each ion of the different mass in mixture. Separation of peaks depends on the relative mass. What is mass spectrum? It is plotted against ion abundance with high mass. Mass spectrum, a plot of the relative abundance of the ions versus their mass to charge ratio. Here, the base peak is the most abundant peak, assigned an arbitrary intensity of 100. The relative abundance of other ions is reported as percentage of abundance of the base peak. Molecular ion, a radical cation formed by removal of a single electron from the parent molecule in a mass spectrometer. For our purposes, it does not matter which electron is lost. Radical cation character is delocalized throughout the molecule. Therefore, we write the molecular formula of the parent molecule in bracket within plus sign to show that it is a cation, a dot to show that it has an odd number of electrons. This is the mass spectrum. Mass spectrum of dopamine. This is a mass spectrometer. Diagram of a simple mass spectrometer. Atomic and mass number. Here Z is the atomic number where A is the mass number. Ways to produce ions. Ionization method, electron ionization, chemical ionization, desorption ionization, spray ionization. Electron ionization, vaporized sample is bombarded with the high energy of electrons. Advantages, it is inexpensive, versatile and reproducible. Fragmentation gives structural information. large databases if EI spectra exist and are searchable. Disadvantages: fragmentation at the expenses of the molecular ion. Sample must be relatively volatile. Chemical ionization: vaporization sample react with a pre-ionization reagent gas via proton transfer, charge exchange, electron capture, adduct formation, etc. The common CI reagents are methane, ammonia, isobutane, hydrogen, methanol. Soft ionization gives little fragmentation. Resolution: there are two types of the resolution, low resolution and high resolution. A measure of how well a mass spectrometer separates ions of different mass. Low resolution refers to instruments capable of separating only ions that differ in normal mass. High resolution refers to instruments capable of separating ions different in mass by little as 0.001 atomic mass unit.